I just wanted to understand, is there anyone who has not attended yesterday's session and only joining today for the first time, or you haven't got chance to watch yesterday's demo video and you're watching, you're coming to today's session and this is the first time? Is there anyone of this category, please? Did you watch the video by any chance? I didn't get any video. Only today I got the link. Oh, you got it from Vivek, is it? I got it from Jeff, I think. Okay, sure. I'll just forward that. I'll just give a 5 minutes of overview of what we have discussed in our previous session. Yep, that helps. Okay. Yeah. So, for the benefit of the people who are joined only today, yesterday we were discussing about what is Hadoop and what is big data, the basic terminology, and then we were discussing about mainly yesterday's session was targeted to concentrate on the course contents walkthrough. We have done a big walkthrough on what all the course contents that we would be covering throughout the course. So that was the total concentration in yesterday's session. And Tejashri, I hope you did watch the demo video, right, Tejashri? So today, what I would convey is, I would like to convey few more aspects related to Hadoop, where it would be used and where it is fitting to, right? So let me start this. Let me take a notepad. This notepad is something that I would be forwarding you probably in a regular interval, because I would do all the groundwork here. Whenever we are having some discussion, either in this notepad or I'll have an Excel where we will discuss everything, right? So because majority of our discussion would be on code part and practical part, so this will have something related to architecture or something apart from what I do show you in the presentation, right? So today I was telling, let me quickly walk you through what is Hadoop basically. Like I told yesterday, Hadoop is a framework that is built to store or analyze big data basically. Okay, that is fine. So how will it accommodate such huge data sets when it was not possible with RDBMS? I told you, Hadoop comes with two major ingredients. One is HDFS, which will call it as Hadoop Distributed File System, and another programming model called MapReduce. In short, we can call it as MR. But of course, MR is slowly becoming obsolete. So, of course, we will concentrate on other architectures which are currently very good in the market, which is like Spark. You can talk about Kafka, and you can talk about many other things. Okay, now coming to this Hadoop distributed file system, what is this? It is group of file systems together, right? That's what I told. So when you bring group of file systems together who can work in a distributed manner and achieve parallelism, that's it. You can probably work with big data in a distributed manner, right? Just so I gave this generic example. Probably LT, you can refer to the previous demo video. You'll get much more clarity on this. Now today I would like to talk about What's a cluster and how it looks like? First of all, like I told, HDFS is group of file systems which are brought together to work in a distributed manner. So those file systems can also be referred as a file server, or it can be called as a CPU, but I would prefer to call it as a node, right? So I have a node which I can call it as a file system or a file server or a CPU, whatever you call it as. But when I have group of that nodes, I will call it as a rack. When I have group of nodes, it's nothing but a rack. When I have group of racks, it's called as a cluster. Okay, so there you go. We have cluster, which is nothing but group of racks, and a rack is nothing but group of nodes. Okay, so here in Hadoop distributed file system, you will have multiple nodes which will be working for your task. And in an ideal cluster, each of these racks will be located in different physical locations. That means rack 1 could be in North America, rack 2 in somewhere else, rack 3 somewhere else. Why is that? Why don't we put all of them in a single place? It's simple. To achieve robustness, we put them in different physical locations, but it's not mandatory. You can place them in a single physical location as well, but it's preferred to put them in different physical locations. The reason is, if one rack, let's say rack 1, has gone down due to power shutdown in North America, I mean the place where it is located. So for that reason, I cannot stop my business, right? It has to continue as usual. So for that matter, rack 2 and rack 3 will take the load of rack 1 and they work and they make the business run as usual. But one quick question you might get is, when rack 1 is down, the data in the rack 1 could have gone down. How would rack 2 and rack 3 accommodate that? That could be a question, right? So there is a concept called rack awareness. What is that rack awareness? So your Hadoop architect, one second. So the rack awareness is nothing but Hadoop architecture is so much intelligent enough that to make sure that it replicates the data. But how would that replicate it? It replicates in a way that even if a node goes down, even if entire rack goes down, you still have your data available. That's the main theme of the replication with respect to Hadoop. That means if your, let's say rack 1 has gone down, I'm fine because I mean my architecture would have copied this data somewhere in rack 2 and rack 3. So even if this goes down, I'm pretty much happy enough. If node 1 in rack 1 goes down, that's fine. I have this data somewhere in other nodes in other racks. So there you go. But you can ask me, hey, why do we have to do replication? Are we not wasting the data? I mean, are we not wasting the space? No, we are not. This is because we are trying to achieve robustness. And again, please do remember, even in any traditional DBMS or any legacy systems you take, this this particular replication is common, but you have to do that manually there, which we call it as RMAN backup, hard backup, manual backup. You can call it in different terms, but yes, replication is happening even in your traditional systems. But admins has to do that explicitly. But in Hadoop, I'm telling you that it will be done automatically by the architecture. So there you go. That's all about cluster, but of course, regarding replication, rack awareness and stuff we will be discussing further more and in more detail when we go to the architecture, right? I just wanted to introduce you with cluster because I have few more aspects to cover related to this concept, right? I have few pings here. A node means, I would say, a physical system which can contribute the space or which can contribute its processing platform. I mean, it can process the data. At the same time, it can store the data. It's like a CPU, which can do both storing and processing of your data, right? That's what a node means. Mukesh, you have a question to ask by any chance?
Okay, I just said it does replicate, but you told us, is it explicitly? What does that mean? Admin has to do on every day, so
No, 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 no.
in the future.
I'm referring to RDBMS because if you take any RDBMS backup, let's say RMAN backup, that has to be triggered by admins every weekend or every non-production hours or something. They would write some automated scripts. That's fine, but that particular thing has to be monitored by the admins in RDBMS, right, Mukesh?
Okay.
But in Hadoop, architecture takes care of it. As a user, you need not bother about it.
Oh, that's so plus point actually.
Yeah, that's correct. I mean, that's a very good point, as well as there is few more aspects on top of replication, which we would be discussing when we go to the architecture. Okay.
Sorry. Yeah.
Okay. That was a question from Sachin. Uh, the data in the node 1 of rack 1 should be replicated into same rack or some different racks. Can you give some idea where they are replicated? No, they will not be replicated in the same rack. Rather, they will be replicated across the racks, because if you copy the data in the same rack and if your entire rack goes down, you are in the same old situation. That means you are losing the data, right? So Sachin, so it will be replicated across the racks. I hope that answers your question. And question from LT. Node means server. Yes, it's like a server or CPU. You can refer to it in any terms that probably you might feel comfortable. Okay. And from VNP, node or cluster has any operating system? Of course. When you're talking about a node, it's nothing but a physical machine, right? And machine has to have an operating system in order to make it work. And yes, it will have operating system, and we will discuss about these operating systems and stuff when we proceed with the architecture. Right, VNP? And you still have any questions? I could see your hand raised.
Yeah. Also, how are the two nodes connected to each other? What protocol they use for communication with each other?
I would say it's a transmission control protocol that they would be using to communicate with each other through a dedicated port.
Oh,
right.
So it's like a TCP/IP communication.
Absolutely. Yep.
Okay. Thank you.
Yeah, no problem. So now you understood what is a cluster, right? Now let me give few more insights about Hadoop and how I can compare RDBMS and Hadoop, because I usually hear this term that Hadoop had replaced RDBMS, but that's a wrong notion. Hadoop can never replace RDBMS, right? But you can say, hey, you are contradicting your statement which you have told us yesterday, because big data is a term to denote larger data sets which cannot be stored or analyzed over RDBMS. That's what I've told related to big data, right? Big data is a term to denote large data sets which cannot be stored or analyzed over regular traditional RDBMS. Okay, that's fine. But I already told you RDBMS is not designed to handle or analyze such huge data sets. This is the thing that I've conveyed. That means RDBMS is not designed for such huge data sets, and Hadoop is designed for that. Which doesn't mean that Hadoop is not gonna replace, which doesn't mean that Hadoop is going to replace RDBMS. That's a very wrong notion. Why? I'll tell you. There are two things: OLTP, OLAP. Okay, I'll revolve. Entire session will be revolving around these two concepts today. OLTP means online traditional, transactional processing. OLAP means online analytical processing. Okay, How different are they? And which concept do we use where? I'll tell you something like, for example, let's take an example of Amazon or any e-commerce. Amazon, let's say, has a product like iPhone 6 or something. So, in its inventory, Amazon has, let's say, some 100 iPhones available, iPhone 6 available. Now, let's say Sumit had purchased, probably Sumit is a distributor, he has purchased 10 iPhones from Amazon, right? And now the count of inventory had come down to 90. Again, Sumit had sold everything and he has purchased 10 more. So now the count had come down to 80. So what is happening here? Here there are transactions that are happening which are updating your total number of iPhones that are present in Amazon's inventory. Not only that, when 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 Sumit is purchasing iPhones from Amazon, what would he do? He would make the payment, right? He would make the payment. That's again a transaction, right? So this comes under OLTP, online transaction processing. I'll give you another better example. Let's say I have some $10,000 in my account, and for some purpose I've used $2,000. Maybe I've made some purchases. Now my account balance had come down to $8,000, and I've got my paycheck. Probably let's say some 10,000, and my account balance had gone up to $18,000. So what is happening to my account there? It's getting continuously updated. So that's bank's headache to update the account balance to reflect the current balance and stuff. Okay, but what is that? It is nothing but continuous updates of your balance of a particular customer, which is nothing but OLTP, online transaction processing. And I would say that RTBMS is a better fit than anything to handle to handle OLTP. Okay, now come to OLAP. Now, Amazon, I told you, had 100 iPhones available in its inventory. After probably 1 week, the Amazon's inventory count had come down to 10. Total iPhones are available in Amazon are 10. Probably Amazon would have set a trigger saying that, hey, whenever I reach this particular limit, alert all the stakeholders so that we can get few more iPhones from maybe Apple store or something. Okay, that's what Amazon had planned. Now, when it comes down to 10, it again comes with some iPhones. So again, its count goes up. So this keeps on happening, right? Now, suddenly, Apple team wanted to understand how their transaction or how their sales are progressing. Maybe Apple's analytic team can take the data from their purchases from Apple Store, or they can go to the e-commerce sites and they can ask them, hey, give me the transactions how iPhone 6 are being sold from your website. So they're collecting the data sets. They would take the data set from their own Apple Store, and then they would collect the data from the e-commerce sites, and they would gather all the data sets and keep it together. Maybe they will gather this information once in a week. Okay, when they gather this information once in a week, look at the data volume. Basically, the volume of the data would be very huge, because maybe Amazon would have sold somewhere around 10,000 pieces. Apple Store would have stored 20,000 pieces. There are other e-commerce sites, right, which eBay and many other sites which would be selling iPhone 6. So all of them, maybe I've given a very smaller count. When you look at it globally, there could be millions of transactions per a week. Now, what would they do connecting all these transactions? They would have to analyze it. They analyze these particular transactions and understand the customer behavior. Maybe they would look at how where their sales are predominantly happening and where their sales are lagging. They wanted to understand this so that they can concentrate on the place where their the market is less and probably try to improve that. So for that, they have to analyze millions of transactions there. So that's where we call those huge volume as big data, and those transformations or those transactions can be better analyzed using Hadoop. OLAP is something that is better in Hadoop. But now, let's look at why RDBMS will not be able to handle OLAP and vice versa. Why Hadoop will not be able to handle OLTP. That gives you a better picture why Hadoop cannot ever replace RDBMS. Rather, they complement each other. How is that? Let's first concentrate on why RDBMS will not be able to handle OLAP. See, when you're generating some millions of records per day in RDBMS, it's fine until it reaches billions. So when it is reaching trillions, that's when it becomes very difficult for RDBMS to handle it. So what happens is, in regular intervals, they dump the data from RDBMS to Hadoop. Let's say every 1 day, after business hours, whatever transactions that are happened today, I will dump it into Hadoop. Maybe that is for analytical purpose or for the storage purpose. Somehow, whatever be the case, I will transfer it into Hadoop from RDBMS. Okay, that is fine. Now, if I don't have Hadoop, what happens? In RDBMS, the data keeps on growing, and at some point, they will think of purging the data which is not required. Maybe, uh, maybe they will put a purge after which are older than 3 months or something, so that they reduce the space optimization. I can refer to it as. Okay, that happens in RDBMS, and that used to happen in many organizations as well. Now, with the introduction of this Hadoop or any big data technologies, what happens is they regularly take the backup of Hadoop, of the transactions or any other daily data into Hadoop. And of course, they purge it from RDBMS because they have the data backup in Hadoop. Now, the data keeps on getting accumulated in Hadoop. But what do you do with that, with accumulated data? Are you going to get anything out of it? Of course. When you analyze that huge data, you would be able to mine the results better, and that creates a lot of positive impact to your business. I'll tell you what. Let's say I belong to a bank credit card analytics team. Let's say. Now, I wanted to give some offers to Siddharth. Especially Siddharth, I wanted to pick a customer like Siddharth and I wanted to give him some offers. Now, I have only last 1 month data. Last 1 month transactions in RDBMS, I've taken that and analyzed Siddharth's behavior. And I could see that Siddharth is using the credit card more for purchasing gasoline. So I've given some offers. Hey, if you use our credit card for gasoline, you would get somewhere like 1% waiver or something. I've told him. So that's the offer I have given to his credit card. But I found that unfortunately I've never used that particular offer. Okay, that's fine. Then I went to Hadoop. I took last 2 years or last 1 decade behavior of Siddharth. Now what I found was he is more of shopping guy. He is purchasing more in e-commerce through the credit card. But he never, the amount or the number of transactions he made for purchasing gasoline through our credit card is less than 1%. That's what I found when I analyzed his last 3 years data. So what's wrong, or where did we go wrong in our earlier analytics? We didn't go wrong anyway, but the only problem is the sample that we picked for analytics was very small, and the insights that I get out of it is very scattered, which might be true or which may not be true because that's only 3 months data, and I cannot ever rely on 3 months data analytics. I would obviously look at some huge data from where I can get more insights. That's a perfect example for that. So will RDBMS be able to analyze one decade data which could be in billions and trillions? Obviously no. But whereas Hadoop, yes, it has the capability and it does that in a very stipulated time frame, I should say. Okay, so that's why OLTP is only fit for RDBMS and OLAP is only fit for Hadoop. But you can ask me, hey, why is Hadoop not being able to handle OLTP? It should be able to handle OLTP as well, right? No, it will not. Because OLTP is what? Continuous updates, row level updates. One has to remember that you don't have row level updates and deletes in Hadoop. For example, I have 1 million records. Out of that, I have to go to a record at the 10th line and I have to update something in Hadoop. No, you cannot do that. You can only append at the last. Probably you can introduce a new file which gets added to the last, or you cannot update or delete row level in Hadoop. So which makes it very clear that Hadoop is not a fit for OLTP. As simple as that. You can delete either entire data set or you can add another data set to an existing data set. You can do these things, but row level updates and deletes are never ever possible with Hadoop. But there are alternatives like HBase, right? Available, and even in Hive's latest version .13, you have the updates possible, but that's not physical. It's logical updates. And how that happens, probably we will do that or we will learn going forward, right? So that's about OLTP and OLAP and why Hadoop and RDBMS always complement each other is this reason, because OLTP happens and the data gets dumped into Hadoop and Hadoop is preferred platform for analytics. So that way both are complementing each other. So I'll stop here for a couple of moments to answer your queries. Yes, VNP, you have any questions, please?
I'm good, thank you.
Yeah. Uh, no hands are raised. Okay. I see some things here. Who is faster, OLAP or OLTP, or it depends upon volume of the data? Yes, your question itself has the answer. It depends upon the volume of the data, right? I mean, I cannot compare OLTP and OLAP because these are two different processing platforms, right, Mukesh? I hope you got the answer.
Actually, I got my own question. I got my answer.
Yeah, cool. And LT, RDBMS to dump the data in Hadoop. Is there a tool to copy the data transfer for such use data? Of course, like LT, there is a tool called Scoop. Scoop, which I've given a briefing in our yesterday's walkthrough. Scoop, SQOOP. SQ means SQL. The first O means import. Next O means export. So SQL import export utility that can bring the data to Hadoop or that can take away the data from Hadoop. That's what Scoop means, right? Scoop is an SQL import export utility which can be used to bring in the data or take away the data from Hadoop. So if you have to update warehouse with late arriving dimensions, is it not possible in Hadoop? No, Sumit. It's not directly possible, but yes, there are alternatives to handle that. That's what I was telling, right? HBase, Hive do handle OLTP, but it's in a different way, but it's not as efficient as your RDBMS. Okay? They'll be used for different purpose. And there is another question. Can we do OLAP in RDBMS? No. When your data is small, yes, you can do it, Raj. But when your data is increasing, that's when you face the problem. When your data is keep on increasing, you'll be not sure. I mean, your RDBMS obviously will not be able to handle such huge data, right? And then you cannot perform OLAP on top of it, right? I hope that it answered your question. Hadoop. Yeah, I'm coming to that, Sidhu. Just give me some time. What is the limit for Hadoop? Is there any? I would say there is no limit. I'll tell you what. See, I'm a project manager, let's say, and there are 10 people reporting to me. and I have a handful of work now that I can give to 10 people. Okay, that's fine. Now I've got so much of tasks that I would need 100 people. Okay, so I would add some racks. I, I would add some racks to my cluster, and I would add 90 people to that racks. So I would make them to work parallelly, and I would make them to complete my task. It's as simple as that. But one has to remember, hey, you're adding resources, you are making them to work parallelly or distributedly, whatever be the case, that's fine. But at the end of the day, you're adding resources, which costs us, right? I mean, this kind of horizontal scaling of resources was not possible in RDBMS, but you are doing so in Hadoop. That's wonderful. That's fine. But at the end of the day, it is increasing cost, right? How do you how do you manage that? Because when your budgeting cost is increasing, no matter whether you are achieving parallelism or achieving distribution, it's a burden for the client, which he may not agree, right? So how are we going to survive in the Hadoop world? And why did Hadoop got so much prominence even that is increasing the budget cost? So the answer for it is no, Hadoop is not increasing the cost. I'll tell you what. There are two types of hardware available in the market. One is enterprise hardware, another thing is commodity hardware. What is this enterprise hardware? Probably let's take example of Teradata from IBM. It's an enterprise hardware. Teradata is made up of enterprise hardware, which is by IBM. So if you are using Teradata, you have to pay these costs to IBM. One is the licensing cost, which is most common cost, and second thing is hardware cost, which is again another common cost. And then there is something called processing cost. That means based on the amount of data that you are running on top of Teradata, you have to pay it to IBM. That will be calculated in GIPS, right? So for that matter, you have to, if you are processing 1 GB of data, you have to pay some cost related to, okay, you have to pay some cost related to uh, uh, processing to IBM. Okay, that's one thing. And there is something called maintenance cost. So if you are in warranty period with IBM, you have to pay some maintenance cost, probably quarterly or annually, because if something goes wrong with your hardware, their team would come and fix that for you. So for that, you have to pay the maintenance cost. So all these costs are incurred in any of your enterprise hardware, right? Now come to commodity hardware. I would say best example is Hadoop, and I don't have any entrepreneur or enterprise version who is supporting Hadoop because it's commodity hardware. So first of all, what is commodity hardware? Commodity hardware is the cheapest hardware available in the market. So that means you will not have licensing cost, you will not have processing cost, you don't have maintenance cost. Of course, you'll have hardware cost, which is pretty common, but that is very minimal. So there you go. Now, having said that, Hadoop doesn't have licensing cost, processing cost, and maintenance cost, which were there in any of the enterprise hardware. Let's compare the costs. If I have to build a Teradata cluster of let's say 10 nodes, and if it is costing me, let's say some $20 million, okay, 10 node cluster is costing me $20 million considering all this costs. Now, let me make it as 50 node cluster of Hadoop. It's still costing me somewhere around $5 to $6 million for 50 nodes. There you go. That's the difference you should observe. That means when you are having enterprise hardware, of course there is someone who can support us when something goes wrong with your hardware. but the amount that you are paying them is very huge, and it's quite very huge. Coming to Hadoop, I don't have someone who supports me. I get the hardware for cheaper cost, and I build some 50 node cluster somewhere for $5 to $6 billion. That is saving a lot of money for me, and that's the main reason why Hadoop has got a lot of prominence. Not only because, Hadoop has got prominence not only because of its distribution or parallelism, but for the cheaper cost it is coming up with. That's why all the middleware or all the medium scale or large scale or the low scale industries have implemented Hadoop, and they are dealing that in production now, right? So I'll stop again here for 2 minutes to make you ask if any questions on commodity and enterprise hardware. I'm anticipating few questions here. Okay, that's a very good question. Uh, what if something goes wrong in commodity hardware? That's the question I'm anticipating. See, when you are getting the hardware for cheaper cost, it can go down at any point of time, right? So that's the common notion, because if I take iPhone 6, if I take a normal phone, which one would I rely on? Obviously iPhone, because of the robustness, or if based on the security it is offering me. Can I rely on the cheaper mobile that I've got on my other hand? No, I cannot. So commodity hardware is a hardware that you cannot rely on. But I would say Hadoop maintains a master slave architecture. Let's say I have 100-member team who are working for me. So I would need only 70 people or 60 people for a particular task, but still I'll have 100 people. So I'll give my task to 60 people. I'll ask them to work. Because I'm getting them for cheaper cost, any of them can go sick. So what I will do is, I'm the master, they are my slaves. So what I would do is, I would route this particular task to someone who is sitting idle. Probably the another 40 people who doesn't have any task, I can utilize one of them. When someone here goes wrong, when someone here is sick. So that's what happened in my cluster as well. It's a master-slave architecture. Masters would be monitoring the tasks that are being performed by the slaves. If something is going wrong, it will utilize other resources available without losing the work they have already done. What do I mean by that? That means if one of the node had completed 50% of the task, right? So there will be very minimal loss even if that particular node goes down, because there is a replication that is happening, right, to some other node. So one has to remember that. So yes, hardware going down in commodity version is very common, but still Hadoop has the capability to do that. And this hardware can be physical or it can be cloud as well. So anything will suffice that. So hardware can be a physical hardware or it can also be in cloud. No, commodity hardware is something which will not be supported by any enterprise version, Siddharth. It's not that commodity hardware is cloud. No, it's not that. Commodity hardware can be in cloud or it can be a physical machine as well. Okay, and what will Hadoop SW maintenance upgrade codes? LT, what does that mean? I couldn't get that.
And see, no, like Oracle for all EBMS, we are paying, say, suppose Oracle we are using. We pay for Oracle the licensing and maintenance, correct? That is not there for Hadoop, sir, for Hadoop?
No, it will not be there because there is no, maintenance cost will be there because your admins itself will maintain it. You have to pay a minimal cost for that. You have to, there will be minimal cost that will be incurred, but it's not as huge as your RP payments. It will be very, very minimal.
So still we will have licensing, maintenance?
Licensing, okay.
See, suppose,
yeah.
Suppose I have 50 users. Is it based on user-based licensing or?
No, you don't have user-based licensing here. I mean, once you build a cluster, it's up to you. I mean, based on the load on your cluster, you can add your number of users, right? So, I mean, there is no user-based licensing here. Okay,
like what do we need to pay any cost for Hadoop or not?
No, we need not. That's what I meant to say here. Commodity doesn't need any cost to be paid. Commodity is coming you for cheaper cost because your hardware itself is not so much robust. That's one thing. And second thing is you need not pay so many costs that you are paying for RDBMS. So these are the two things that is making commodity hardware so cheaper. But like I told, when your hardware is not so robust, they can go down. Yes, they can go down. But I have the backups for that to take care of it. So I'm good, right? And I need not do any manual intervention there. And I have my architecture which is so robust, which will take care of everything. The hardware failures, as simple as that, right, LT?
Yeah. So means do we need to install in each and every cluster, or is there something server level?
I mean, you can do that. I mean, the cluster, if you have a single cluster, you have multiple nodes, let's say 20,000 nodes or 40,000 nodes. Even there are clusters of 10,000 nodes. Facebook is maintaining 20,000 nodes. So what they do is they have an automated tool, Cloudera Manager or different tools, Ganglia, which admins will take care of. I mean, through that, they will do the installation in all these nodes. Ganglia, different admin tools are there.
So is there like a server level installation and client level, node level installation?
Yes, it will be there. It will be there on node level installation as well, because few nodes will be configured for few things and other nodes will be configured for other things. So you have to do a node level configuration as well as.
Okay, thank you.
Yeah, but that's admin task.
Yeah. Just
oh, sorry, you're asking something. Okay. Go ahead, LT. You're saying something?
Yeah. No, just whether you want, just I want to know whether we need to load in all.
Yeah. That will be taken care by admins.
Okay, thank you.
Yeah. Okay. Sidhu, did you get that now? Why commodity hardware is cheaper? Okay. What does the hardware here refer to? Cluster? Raj, you have to understand cluster is group of rack is group of nodes. I'm referring to the hardware when I refer to the nodes, because node is a physical machine, right? Which will have the hardware. I'm referring to that. Any other questions, anyone? Oh, Raj, I hope I've answered your question. And I see. Yeah. BNP, you wanted to ask something? Of course, you can use Linux racks. Rack is group of nodes. In that, the operating system of the nodes could be anything, CentOS or Linux or whatever it is. No, you will be usually on mute, everyone. If you want, you can raise your hand. I can unmute you. Now I've unmuted you, VNP. You can go ahead.
Okay, good. Thanks. Yeah. So my question was, since Hadoop is dependent on RDBMS file system, right? What about the hardware we use for RDBMS? It's a community hardware or enterprise hardware?
No. See. Hadoop is not dependent only on RDBMS. See, wherever I get the data from, I'll depend on that. See, RDBMS would have already been there with many organizations. They have their data. So what do they do with the historical data? Because you're talking about only 3 months data when I'm talking about 1 decade data. So I keep on dumping that particular historical data to Hadoop. It may not be only RDBMS. Maybe I get the data from social media sites like Facebook or Twitter, or I can get the data from different file servers. I've just given one example here with RDBMS, but slowly we would learn many things. How to take the data from social media sites, or how do we take the data from different file servers. So all these are data. Wherever I'm getting the data, which is my source, I will depend on that. It's not just about RDBMS, because most of you will be aware of RDBMS. I've taken that example.
I see. Okay, thank you.
Yeah. So That's it for today, guys. And I'll tell you what's the plan is for our next session. The plan is the next session would be happening on our next Monday evening, which is your 13th evening, or Indian Tuesday morning, which is 14th morning. So that will be our next session. That means you have 3 days time frame here. So what you should do with this within these 3 days? I'll talk to your consultancies, I'll get your names and email IDs. What I would do is, I will send you three things: Linux, Core Java, and Python videos. Maybe once in every day, spend 1 hour and watch these videos because all of them are 1 hour videos. Linux for 1 hour, Core Java for 1 hour, and Python for 1 hour. If you can utilize next 3 days for watching these prerequisites, and when you come back on Monday evening or Indian Tuesday morning, that's when you will be you will be at least comfortable with the basics of this. And I would be talking about how do we use this basic knowledge you have and work on the case studies. So that's my main motive. So I would share the tutorials with you. So what you're supposed to do is, you're supposed to watch them and come back for Monday evening session. And I'm also gonna change the meeting link. I'll send a fresh meeting link from Monday evening. You'll get a fresh meeting link from your consultancy folks. You can use that for joining the session. For others who are directly connected with me, I'll be sharing it with you directly. Okay. Yes, Mukesh. It could be the same time. It will be the same time. The timing will be 6:30 a.m. IST or 9 p.m. EST or 8 p.m. CST. That's the timing of our sessions going forward. But starting from Monday evening, we are going to have session 6 days a week, right? Among that, probably 1 hour I will be utilizing for product development, right, which will be from second week. First week I will be concentrating on architecture and prerequisites. From second week, I will be talking about, we will work on some product development, for which I'll split your batch into two groups, and each group will be working on some specific tasks. So one hour a week I will be utilizing for product development. So that's the plan going forward. We will be using a pseudo mode cluster searching. If you are interested, I would let you know how to. Because we need not build a very huge cluster, because after all we are dealing with development and data analytics, right? So if you are someone who wanted to work on a multi-node cluster, I would let you know how you can install it in Amazon AWS, right? Raj, you have something?